Hello friends, here application of differential equation, and in this video we are going to discuss the concept of velocity and acceleration, and hereby I will give you the complete methodology and aspect that how some application of differential equation are useful in velocity and acceleration. Well, let's see velocity and acceleration. What is the concept? So as I told you earlier, velocity and acceleration, these are associated to each other perfectly. Like velocity, if we are going to find out, it means it is the vector when something is moving in a proper speed as well as in the proper direction. So we said that that calculation is known as velocity. So how the differential equations are useful in this thing? So my dear friends, like velocity, it alludes to the speed of an object in a given direction. So it means the rate change of speed is known as velocity. Can I say that? Velocity is what? Velocity is displacement with respect to time. So if we are talking about in a particular time, in a particular direction, the rate change in speed or that displacement, that known as velocity. As well as what is acceleration? Acceleration is what? Acceleration just implies to the change in velocity. So if we are talking about rate change in velocity, that known as acceleration. And here we will try to find out the acceleration with the help of differential equation. So average acceleration is what? Change in velocity with respect to time. So my dear friends, these are the fundamental and the basic definition of velocity and acceleration. But how we are going to implement some differential equation in order to find out the some questions related to velocity as well as acceleration. So let's see. First of all, let's just go to the depth of this concept, where the velocity will occurs and how the acceleration will becomes and how which kind of questions we are going to discuss. So let's see, my dear friends. Here you can see a one figure I'm just giving to you first of all, and in this figure you can see here when a car moves a distance x meters in a time t seconds along a straight rod. If the velocity v is constant, then v is equal to x by t meter per second. The gradient of the distance per time graph shows in the figure number 44.1, and here I just give you a one figure, and here you can see, my dear friends, with respect to time t, the speed is moving, the distance is covering, so it means the speed is what? That speed is constant. Okay, so here you can say that velocity v is what? Velocity v is a constant. So it means, is there any effect of derivative? No, my dear friends. Like the car is moving with a proper speed with respect to time, and there is a speed is constant. Like if it is moving in a 30 kilometer per hour, so it is moving at 30 kilometer per hour. There is no change with respect to time. Okay, like if you are saying like after this time, after 5 minutes, after 10 minutes, the speed will be increase. So you can say that there is something change in the velocity, there is something change in the speed. So the point is that here just you are saying that v is what? V is directly x by t. So the direct effect of x with respect to t is known as velocity, because velocity is constant. But in the other figure you can see the figure number 44.2. What is it in this? So here the velocity is not constant. You can see if however the velocity of the car is not constant, here I'm just not taking a constant velocity, then the distance with respect to time graph will not be a straight line. It may be shown in 44.2. If the velocity is not constant, so the graph will becomes like that. You can see here. And if the velocity is constant, so graph will becomes like that. So the average velocity over a small time, that is a delta t, and the distance is delta x. So what is the change here? Delta t is, say, we can say that the change in time, and delta x but the change in distance, because we have two things, there are the distance and the time. So if the time is changing, that is a delta t. So there is a change in distance, that is a delta x. Okay, so and that change is what? That change is occurred that delta x by delta t. As delta t tends to 0, the chord AB becomes a tangent such that the point A and the velocity is given by v is equal to dx by dt. So here you can see that the dx by dt, the rate of change of x with respect to time, and the rate of a change in the speed with respect to proper time is known as a velocity. So here you can see with respect to time, the thing is just little bit change, you can see. So that's why I just appear that dx by dt is equal to v, that is known as velocity. So in order to find out velocity, we need to know the derivative approach. So directly, if you are applying the derivative on the distance function with respect to time t, so what is the change in distance? What are the car is covers, how much kilometer that it covers in proper time, that is velocity. And how we find out? With the help of derivative. So this is the application of derivative, and further we will just go through the acceleration also. So let's see, my dear friends. So here you can see that for the distance x is known in the terms of time t, then the velocity is obtained by the differentiate the expression. Okay, that is the dx by dt. So further see, here I'm just giving you another figure that is 44.3, and here you can see the one axis is known as velocity and other is time. But in the last figure, you notice that one axis is known as the distance and other is time. So we was measuring the change in distance with respect to time, but now we are going to measure the change in velocity with respect to time, and the change in velocity with respect to time is known as acceleration. Okay, that the change in time, that is delta t, change in velocity, that is delta v. So that is acceleration, nothing else. Okay, let's see. The acceleration a of the car is defined as the rate of change of velocity. So a velocity with respect to time graph is shown in the figure 4.44.3, you can see here. Okay, so delta v is the change in v and delta t corresponding change in time t. So a is delta v by delta t. Okay, so a is what? That is dv by dt. You can see there dv by dt is what? A, and a denoted to acceleration. Clear? So it means a is acceleration and it is denoted by dv by dt, and v is what? That is dx by dt. Already we have done. Is that dx by dt? X is a distance function. Dx by dt we have done. So a can be written as d by dt and dx by dt because I'm just replacing the value of what? That is the value of v here. Because you have v, so I'm just replacing the value of v in this equation. So you got a is equal to this thing. So it will become a double derivative of x with respect to time t. So it will be, say, time t, d2x by dt square. So the acceleration is given by the second differential coefficients of a distance x with respect to the time t. So acceleration is always appear with the help of double derivative equation, and velocity is always appear in the single derivative equation. Okay. So in the complete aspect of velocity and acceleration, even when we are going through to the complete questions, I will give you some examples, 4 or 3 examples here I will provide you. So before that, I hope so that we understand the concept now. What is the velocity and what is the acceleration? How we are going to implement some differential equation. And here I am providing you complete summary for today's lecture, that summarize if a body moves a distance x meters in a t second, then what? So you have a distance that is x, and your some body could be a car or whatever. So there is a displacement, the change in distance, that is x. So if you are finding the change in distance with respect to time t, that is known as velocity. Here you can see that is known as velocity, dx by dt. Similarly, acceleration is was, that is dv by dt. A is equal to dv by dt, and after double dash you can say that d2x by dt square, which is gradient of the velocity time graph. So my dear friends, this was the complete aspect of velocity and acceleration. It was the concept actually. So if someone is confusion about the velocity and acceleration, now you have a clear picture about a velocity and acceleration. Velocity has a single derivative of a distance function, and acceleration is a double derivative of that distance function, because acceleration is a rate change in velocity, and velocity is the rate change in that body, or you can say that the displacement. Okay, so in the next lecture, we will discuss some problems related to velocity and acceleration, because the implementation of differential equation is depend on the problems, and we will see more and more problems from this topic. So thank you so much for watching this. Bye bye.